Imagine yourself standing beneath a sky filled with countless shimmering stars, gazing out toward the vastness of space. All around you, the known planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, dance gracefully around the sun, bound by its invisible threads of gravity. But is that truly the full extent of our cosmic backyard? You see, when most people picture the solar system, they envision our sun at the center, orbited by these 8 familiar worlds. Maybe they'll even toss in Pluto, the beloved dwarf planet, still holding a special place in our hearts. Beyond Pluto and Neptune lies the Kuiper Belt, a vast field of icy bodies, rocks, and dwarf planets gently circling the sun in a sprawling disk of debris. This region alone stretches from about 30 astronomical units. 1 astronomical unit is roughly the distance from the Earth to the Sun, about 150 million kilometers, all the way to about 50 astronomical units. The Kuiper Belt is fascinating, and it's right there, on the edge of what we typically think of as our solar family. But friends, the story doesn't stop there. Beyond the Kuiper Belt, far, far beyond it, something extraordinary happens. Something fascinating. We begin to enter a zone known as the Oort Cloud. Now, the Oort Cloud isn't exactly something you can point a telescope at and snap a quick photo of. It's something much more elusive, mysterious, and yet incredibly important to our understanding of the cosmos. So, what exactly is the Oort Cloud, and why does it matter? Let me paint a picture for you. Imagine, if you will, an enormous sphere, a vast bubble of icy objects surrounding our entire solar system. Not flat like the disc-shaped Kuiper Belt, but a gigantic spherical shell extending in every direction, encasing everything we know, like the shell around an egg. But don't picture it as dense or crowded. Rather, imagine it as incredibly sparse, unbelievably vast, stretching thousands of times further than the distance between Earth and the Sun. Scientists estimate this colossal sphere begins roughly around 2,000 astronomical units from the Sun, already well beyond our current spacecraft, and it stretches out possibly as far as 100,000 astronomical units, maybe even 200,000. That's nearly halfway to the next nearest star. But wait a minute, if we've never actually seen it directly, how can we be sure it's there? Now we're asking the right questions. Let's explore that a bit more. For centuries, humanity has been fascinated by comets, those ghostly celestial visitors with brilliant tails stretching across the sky. Comets have appeared in myths, legends, and historical records, from ancient Babylonia to Rome, from ancient China to medieval Europe. They've been viewed as omens, heralding great events, sometimes good, often disastrous. We now understand these comets not as supernatural phenomena, but as icy objects from the far reaches of our solar system, heated by the sun, leaving spectacular trails of dust and gas. In the 17th century, astronomer Edmund Halley changed our understanding forever when he predicted the return of the comet we now call Halley's Comet. His prediction proved that these celestial wanderers followed predictable orbits. Some comets, like Halley's, have short, predictable journeys, returning to us roughly every 75 years. We call these short-period comets. But there's another class, long-period comets, whose journeys span centuries, millennia, or even millions of years. These comets arrive suddenly, traveling from random directions, making one dramatic appearance before disappearing back into the darkness. Here's where things get intriguing. Astronomers began wondering, where do these mysterious, long-period comets originate? In the early 20th century, scientists observed something strange. Long-period comets weren't just coming from one direction. Instead, they seemed to approach from all angles, as if our solar system was surrounded by a gigantic reservoir of icy bodies. A Dutch astronomer named Jan Oort analyzed these cometary orbits carefully in the 1950s and proposed a groundbreaking idea. Perhaps these comets came from a spherical cloud of icy objects far, far away, so distant that their gravitational connection to the sun was tenuous but still present. This hypothetical cloud was named the Oort Cloud, honoring his pioneering insight. Since then, astronomers have embraced this theory. Yet, no one has actually seen the Oort Cloud itself. So how do we know it's real? Imagine you're sitting by a lake and you notice ripples in the water. You can't see the pebbles someone threw into the lake, but the ripples are evidence something fell into the water. Likewise, long-period comets are the ripples, and the Oort Cloud is the unseen source. So what's life like in the Oort Cloud? It's cold, unimaginably cold. Temperatures are just a whisper above absolute zero. The sun out here is barely brighter than any distant star seen from Earth. Objects floating in this dark region are icy rocks and small comet-like bodies, frozen solid for billions of years, left undisturbed since the solar system's formation. These icy relics hold clues about the very birth of our planetary neighborhood. Occasionally, gravitational disturbances from passing stars, galactic tides, or interactions with unseen masses nudge these icy bodies inward, sending them tumbling toward the inner solar system. That's when we see them as brilliant, breathtaking comets illuminating our skies. So every comet we witness is actually a messenger from the edge of our cosmic home, a piece of ancient history traveling millions of kilometers to meet us. Now you might be wondering, can we send a spacecraft to explore the Oort Cloud directly? As exciting as that idea sounds, there's a major challenge. Our fastest spacecraft, NASA's Voyager probes launched in 1977, have traveled continuously for nearly half a century. Yet Voyager 1, the fastest spacecraft we've ever built, is currently around 160 astronomical units from Earth. At its current speed, it would need tens of thousands of years to traverse even a fraction of the Oort Cloud's vastness. To reach and explore the Oort Cloud directly, we'd need technologies far beyond what we currently possess. But even though we can't yet explore it directly, studying the Oort Cloud helps scientists understand how our solar system formed and evolved. It challenges us to think about the boundaries of our neighborhood, urging us to question what it truly means to belong to our solar system. Interestingly, scientists theorize some objects in the Oort Cloud may not even have originated here. They could be interstellar wanderers captured billions of years ago, when our sun was young and lived among countless sibling stars in a stellar nursery. So perhaps the rocks at the solar system's edge aren't all native to our sun. They might have journeyed from other stars, other planetary systems, cosmic visitors who found a permanent home here. That brings up another fascinating thought. As distant and obscure as the Oort Cloud is, it reminds us of how interconnected our galaxy truly is. It shows that even our solar system isn't a neatly defined island. Instead, it's part of a dynamic neighborhood, continually interacting with the stars around it. Today, astronomers continue to look for new ways to confirm the existence and nature of the Oort Cloud. Future telescopes, advanced observational techniques, and next-generation spacecraft may one day offer us glimpses of these icy objects. Until then, we marvel at its mystery, guided by indirect evidence, theoretical models, and the awe-inspiring journeys of comets. In exploring the idea of the Oort Cloud, we've traveled together to the outermost reaches of our cosmic home, touched the very edge of our star's influence, and confronted mysteries still waiting patiently to be solved. The Oort Cloud is out there, reminding us of how much is left to discover, to understand, and to marvel at in our cosmic journey. Thank you for taking this journey with me through the cosmos today. Keep looking up and stay curious, because the universe is vast, fascinating, and it always has more wonders waiting just beyond our view.